This is a review for Module 7 of Exploring Creation with General Science. The topic of this module was the fossil record. I thought that we would start by going over the study guide, and question number 1 asked you to define the following terms. Fossil. A fossil is the preserved remains of a once living organism. Petrification. Petrification is the conversion of organic material into rock. Resin. Resin is a thick, slowly flowing liquid produced by plants that can harden into a solid. Extinction. Extinction is a term applied to a species that was once living but now is not. In addition to those 4 vocabulary words, when you take your test, you will need to be familiar with the following vocabulary words. The fossil record. Remember that the fossil record is the sum total of all discovered fossils. Carbonization. The process by which an organism's remains are converted to a filmy residue that leaves a flattened drawing of the organism in rock. Here's a photograph of a carbonized fossil. Notice the incredible detail in the photograph. These carbonized fossils are even more detailed than the first one. The vast majority of carbonized fossils are made up of plant materials such as leaves. Leaves themselves are fairly flat to begin with, and in the carbonization process, recall that the water and other materials that make up the organism are actually squeezed out during the carbonization process. And so it is the ideal type of fossilization process for things like plant materials and insects and fish. In paleontology, a cast is the shape formed when sediments or magma fill a mold. And recall that a mold is the impression formed when an organism is surrounded by rock before it decomposes. Here we have a photograph of a mold and cast fossil, and here are 2 more photographs of mold and cast fossils. Remember that a mold and cast fossil only provide information about what the outside of an organism looked like. A placoderm is a class of extinct fish with bony plated armor and primitive jaws. Here's a photograph of a placoderm fossil and an artist's concept of what a placoderm may have looked like. A trilobite is an extinct marine creature that had a segmented body that was divided by grooves into 3 distinct lobes. Here's a photograph of many trilobite fossils all together. Some are casts and some are molds. And here's another very clear photograph of a trilobite fossil. Back to our study guide. Number 2, when a plant or animal dies, what is the most likely thing that will happen to its remains? Remember that the vast majority of things that die on Earth will actually decompose. The fossilization process is very rare and represents only a tiny, tiny fraction of the organisms that have existed in Earth's history. Number 3, which forms first, a fossil mold or a fossil cast? Remember from our experiment, 7.1, that a mold forms first. Number 4, describe the process of cast forming, indicating when the mold has formed and when the cast has formed. First, a dead organism gets buried in sediment, and as the sediment hardens and turns to rock, the rock surrounding the organism hardens around it. As time goes on, water seeps into the rock and the dead organism decomposes. When the rock is split, an empty mold is left behind. If other sediments seep into the rock that contains the mold and fill that space, as time goes on, those sediments will harden, forming a cast of the original mold. In experiment 7.1, you were asked to simulate the process of mold and cast fossils forming. You'll note in this photograph that the impression of a seahorse has been pressed into the clay and allowed to dry. And then plaster of Paris has been poured into the mold, allowed to dry, and then pulled out from the clay, and it has formed a cast of the original seahorse. Number 5, what is required in order for petrification to occur? The thing that's required is water that's rich in minerals. Remember that petrification is the result of an organism's remains being exposed to these mineral-rich waters. And mineral deposits begin filling in the pores that naturally occur in the outer layer of the organism. When the organic material decomposes, all that is left behind is the minerals. Experiment 7.2 was designed to show you what happens when water that's rich in minerals evaporates. And if all went well for you, you should have seen that the minerals that we added to the water were actually left behind when the water evaporated. Number 6, why does petrification usually produce fossils with more information than fossil casts? Remember that a cast of an organism only shows what the outside of it looked like. The center of a cast is just rock. Meanwhile, in petrification, the remains of the organisms are actually replaced little by little, so it allows for more detail and more structure of the organism to be preserved. Number 7, can you learn much about the thickness of an organism from carbonized remains? The simple answer is no, because carbonized fossils are flat. Remember that during the carbonization process, most of the material that made up the organism was squeezed out of it, so it's lost. So in the end, carbonization really just forms a detailed drawing of the organism in stone. Number 8, what type of organism is most likely to leave carbonized remains? That would be plants. Experiment 7.3 was designed to simulate, at least to a certain extent, the carbonization process. You were supposed to press some leaves between two pieces of paper. And so experiment 7.3 was able to simulate the pressure that is involved in the carbonization process. However, it wasn't able to simulate the chemical reactions that go on or the heat that occurs during the carbonization process. But if all went well for you, then you should have noticed that at the end of experiment 7.3, there were definite leaf impressions left on the surface of the paper. Number 9, what's so nice about fossils that have been encased in amber or ice? Remember that amber and ice actually enclose the organism in order to preserve it. And so scientists can get a lot more detail from these kinds of fossils. Here we see a photograph of a mammoth that had been encased in ice, and so it was preserved as an ice fossil. And we also see a photograph of what looks to be an insect that was encased in amber, and so it would be an amber fossil. Note the detail that scientists are able to get from these kinds of fossils. You see the actual organism still preserved. You can see what kind of skin is on the mammoth. You can see the color of the mammoth. And the same with the insect. You can see what its exoskeleton looked and where all of its natural parts fell while it was still living. Remember that scientists have actually been able to extract DNA from insects that have been encased and entombed in amber. Number 10. What are the 4 general features of the fossil record? First, fossils are usually found in sedimentary rock. Since most sedimentary rock is laid down by water, it follows that most fossils were laid down by water. Very few fossils have been found in igneous rock, although that is possible, and very few fossils have been found in metamorphic rock. In addition, the vast majority of the fossil record is made up of hard-shelled creatures like clams. Most of the remaining fossils are either water-dwelling creatures or insects. Only a tiny, tiny fraction of the fossils that we find are plants, reptiles, birds, and mammals. And that actually should make sense to you because most of the fossilization processes are time-consuming, and soft-bodied creatures actually decompose before they can become fossils. Hard-shelled creatures and things like bone endure longer, and so they are around long enough for the fossilization processes to take place. Many of the fossils we find are of organisms that are still alive today, and many of the fossils we find are of organisms that are now extinct. And I think one reason that Dr. Weil wanted to point that out is because often when we read about fossils, the focus of our reading is on creatures that are extinct. And so he wanted to point out to you and emphasize the fact that many fossils that we find are of organisms that really are still alive today in some form or another. The fossils found in one layer of stratified rock can be considerably different from the fossils found in another layer of stratified rock. Here you have a diagram of stratified rock, and you'll notice that the vast majority of the fossils found in this diagram are of gastropods. Gastropods are shelled creatures. Just about every layer in this diagram contains a gastropod. When we remove the gastropods, however, notice that there are very different kinds of remaining fossils in the layers. Number 11. What kinds of creatures make up the vast majority of the fossil record? Again, that would be hard-shelled creatures. We sort of already reviewed that. Number 12. Approximately how many species of plants and animals have gone extinct in the last 400 years? Would that be 100, 1,000, 10,000, or 100,000? According to scientists who actually study extinction, about 1,000 species of animals have become extinct over the last 400 years. 484 of those species were animals, and 654 of those species were plants. Number 13. What is a trilobite, and are trilobites extinct? You read about trilobites and placoderms when Dr. Weil was discussing the layers of the Grand Canyon. Remember that trilobites are water-dwelling creatures that have exoskeletons. They are assumed to be extinct because we haven't found any living trilobites. Number 14, what is a placoderm, and are placoderms extinct? Placoderms were fish that were covered with bony plates instead of scales, and they are also assumed to be extinct because we haven't found any living placoderms. Number 15, what is the uniformitarian explanation for how most sedimentary rocks formed? Remember that uniformitarians make the assumption that the present is the key to the past. And so uniformitarians believe that in order to understand what happened in the past, we merely have to study what is happening today, because things remain uniform. Today, most sedimentary rock is laid down in layers that slowly accumulate and slowly harden, so they slowly become rock. What is the catastrophist explanation for how most sedimentary rocks formed? Catastrophists also make an assumption, and their assumption is that a good fraction of the geology that we see today is the result of processes that occurred once in Earth's past and will not be repeated. Therefore, sediments can be laid down quickly and still be in layers during a catastrophe. And we actually have some evidence of this because after the Mount St. Helens volcanic eruption, mud flows actually formed a canyon with stratified layers that we were able to watch in real time. And so we were able to watch that formed in real time. Number 17, what is the uniformitarian explanation for why different fossils are found in different strata? Uniformitarians believe that different fossils are found in different strata because the layers were laid down one at a time and different organisms lived in the area during the time the layers were deposited. We'll go back to our diagram. And so according to uniformitarians, each layer represents a different historical time period in Earth's past. And so during one historical time period, certain creatures lived in the area, and certain sediments were deposited, and certain creatures' remains were fossilized. At another point in Earth's history, another set of creatures were living in the area. Another set of sedimentary deposits were formed and hardened. The fact that certain creatures appear in one layer and don't appear in another layer simply means that during the time period that those creatures are not found in a layer, they didn't actually live in the area. Remember when Dr. Weil was discussing the Grand Canyon, he talked about how scientists believe that Arizona was covered during one era in its history with an ocean. That ocean encouraged the growth of certain organisms, and when those organisms died, they fell into the sediment at the bottom of that ocean. And as that ocean dried up and geological processes occurred, they hardened into a layer of rock. At another point in Earth's history, another ocean covered that area, and new creatures or different kinds of creatures may have lived there. Some of the creatures may have been the same, though, because we see that some creatures are in multiple layers. And when those creatures died, they fell into the sediment at the bottom, And as that era's ocean dried up, they hardened into another layer of rock, and so on and so forth. Number 18. What is the catastrophist explanation for why different fossils are found in different strata? Catastrophists believe that different fossils are found in different strata because the layers were laid down during a worldwide flood, and different organisms died and were caught up in the floodwaters at different times. Looking back at our diagram, certain creatures, according to the catastrophist point of view, would have been caught up at the beginning of the flood and laid down as a layer of sediment, and other creatures were caught up in a different phase of the flood and were laid down in a different layer of sediment. Remember that he said that during one phase of the flood, the waters may have been churning very violently, and at another phase of the flood, the waters may have been churning more gently, and as things calmed down, water may have been flowing very gently even. And so different organisms would have been caught up in different phases of the flood, laid down in different sedimentary layers of the flood, and that is why we see them at different layers. Number 19. What major speculation must uniformitarians make when studying geology? And then number 20. What major speculation must catastrophists make when studying geology? Remember that at the end of the chapter, Dr. Weil had a brief discussion about which view, uniformitarianism or catastrophism, was right or wrong. I don't think he actually came to a solid conclusion. I think that he would prefer that you come to that conclusion yourself. But one thing that he did want to point out was that each of these major theories are built on certain assumptions, which we've already discussed earlier in this review, but also they are built with lots of speculation because we can't go back in time and actually watch what happened. The major speculation of the uniformitarian view is how the geological processes that we see today would be affected by the time span of hundreds of millions of years. And the major speculation of catastrophism is how the geological processes that we see today would have been amplified in large disasters, like a worldwide flood. That concludes our review of the material in Module 7 for Exploring Creation with General Science. Good luck on your test.